The biggest thing that Rupa kept telling us was to just create a sanctuary for learning. This was a sort of a passion project for her. It was part of why she wanted to come to India. The land was kind of the biggest hurdle, and so we went on, countless drives out into the country. We explored Pune, Karjat, Alibag, looked at a lot of different places around Maharashtra. The site is a beautiful one. To get to that valley, you go through the sort of Oxford golf course, and it's a little past that between the Flame campus and the village of Lavale. It's just to the southwest of Pune, so it's has access to all of the infrastructure that Pune does, but at the same time it's still quite agrarian. They've found a way to work this out on a kind of a very long-term lease. Because this was part of a township development, the township needed to build certain resources for the township to be approved, and this was one of the resources that they needed, so it was a kind of a good give and take of those shared resources. It's a sloping terrain, and so from one end of the site to the other, there's a fairly generous drop. There was an existing kind of excavation that had been there that, as we were starting with everything, there was already a water resource that had been there. One of the first decisions we made was to kind of formalize that into an open well that would be not just something where we could kind of take the spring water that was coming along, but also use that as a catchment, and we implemented kind of recharge pits throughout the site that would help to recharge the water table. And basically, the more capacity we could build throughout the year to hold that water, the sort of easier it would be on our resources. We've actually been able to implement another massive rainwater harvesting pit that exists below the soccer field. What we worked out was a series of sort of buildings that would sit, again, as much as possible, following the natural contours of the hill. And the reason for that as well was to try and maintain as best we could the natural slope. Bedrock foundation of the site is fairly close to the surface, and so any excavation that we had to do was quite expensive. The aspirations that they wanted to accommodate it greatly exceeded the FSI that we were allowed to build, where originally we'd planned for 9 buildings. And when we sort of took those for plan check, very quickly we were sort of cut back to, okay, this is too much square footage, you have to take this out, you have to take this out. That's why we tried to look for ways to kind of maximize what we could build in terms of how much of the verandas were counted in the FSI, outdoor spaces, double heights, things like that. So there's dormitories, there's obviously washrooms, kitchen, cafeteria, things like that. And then the academic program, there's a library space that has, it sort of has become this multi-purpose space. They play football there, they play badminton, they have, poetry recitals and concerts. The program, I don't want to say that it was conventional, but for us what was, I think, paramount was trying to maintain flexibility, to enable them to create a variety of spaces in terms of scale and function. If you imagine each of the classrooms as a cell, those are somewhat standard, but that they were sort of infinitely reconfigurable. On every building, the lower 2 floors are academic, and the upper 2 floors are residential. And so what we wanted to do there throughout the campus, to have the dormitories and the classrooms be in every single building. You have every part of the campus active at all times, and so it's stratified vertically. A lot of the studies that we did found that sort of very typical campus plan is this is my residential zone over here and this is my academic zone over here, and that they never interact with each other. In cities, when you segregate, let's say, office space with residential space, the residential space in the daytime becomes a dangerous place to be, and the office space at nighttime becomes a dangerous space to be. And so we wanted to try and sort of unify those so that at the very least that the diagram, they would stack this way. Obviously there'd be some amount of overlap, but that they would sort of be spread throughout the campus and therefore kind of energize every corner. Knowing that this would be the first time living away from home for most of these young women, we wanted to try and create a greater number of smaller buildings. Rather than have kind of one concentrated campus that had wings, we wanted to sort of create separate ones that, you know, the girls would move through a landscape to connect to different buildings at different times. But with the dormitories especially, I always joke that it's the Harry Potter, method, that you'd have Slytherin here and Gryffindor. And by having sort of these smaller groups, the bonds would be maybe that much stronger. The first one we built was, science, technology, engineering, math. The library is here. This is the leadership center. There's a cafeteria and some classrooms in the lower floors of this one. This one is kind of arts and humanities. We know that it is an institution, but at the same time we didn't want it to feel institutional. And by having these kind of very, very simple, kind of dumb boxes, very basic column beam slab structure. It's pre-stressed post-tension slabs. We tried to sort of make a series of modules that would be efficient for both classrooms and dormitories, circulation of staircases. The leftover spaces we've tried to work out as verandas. Because of the slope, there's an 18-meter drop from this point to the lowest point here. In places where the buildings are sort of parallel to the slope, the foundations become the easiest because of the section. In places where it was longer, we dug these in. This whole floor in the back is below grade, which means that you enter it actually the first floor level, and then you have a kind of double height space which has the library down below. So the most kind of level-ish part of the site was sort of here in the middle. We tried to create this this arrival courtyard, and we'd planted a rain tree where there'd be, buses coming in, cars, kids getting dropped off, the commuting students, and there'd be this sort of moment of arrival where you have the leadership building in front of you where some of the administration offices are. You'd have the library to your right-hand side, and then one of the academic buildings here. And then from that to try and create these little slip passages. This one has a staircase that goes down to this little courtyard below. You kind of come through here and around to go up. The spaces that were sort of left between the buildings, those were generally footpaths. We've paved them with reclaimed stones, but they're fairly heavily landscaped in terms of grasses and shrubs and trees. We've brought in permaculturalists, and we have somebody in our studio who's also quite passionate about it, and we worked with a local landscape architect as well to make as much of the landscape as possible productive. And the girls themselves, as a part of initiative of the school, have gone and even taken it further and started a kind of vegetable garden. They produce a lot of the food that they consume themselves in the cafeteria. We really looked at the kind of local architecture for inspiration, looked at the idea of these running balconies that you see all over Maharashtra, but certainly in Mumbai and in Pune, and the idea of the veranda. The veranda as protection from the sun, protection from the rain, a place to dry your clothes, a place to hang out in the evening, a place to sort of stand and view your neighbor. And so the kind of social dynamic of that, the practical dynamic of that, the implications on FSI, all of those kinds of things. We looked at it as a way on the classroom level where girls could get, if they were ahead in their studies, they might go out and sit on a charpai and read the next chapter or take up some other interest. If they are having difficulties in class, they could get a little bit of extra attention with their lessons, but also spaces where they could socially hang out and just kind of engage with each other. We were really adamant to do single-loaded corridors rather than double-loaded, to just, again, as much natural light as you can have. And the bamboo screens were kind of a way to mitigate some of that in terms of shading, in terms of privacy, but to still have these open verandas that would connect everything and really become the fabric of the sort of shared experience. The building is very basically divided into the 4 floors. Generally on the south side, we would have the veranda spaces. On the upper floors, we would have the dormitories, and those dormitories had single-loaded corridors on both sides. Again, working with the slope, this would be the downhill side, and this would be the uphill side. We were fortunate enough to work with Pratik Raval from Transolar in New York. They're climate engineers. And we started to engage with him on how we might make this a little bit more passive in terms of energy consumption. And he actually suggested that we could do the entire campus without any air conditioning at all. The best way, or the easiest way that we achieved that, was to actually take the building, split it down the middle, and rather than have, if we had columns on the outside and we had sort of a row of columns in the center, was to just build a double wall throughout the middle of the building, which would enable us to have an open shaft for air circulation. What that effectively became was the idea of a solar chimney. The sun heats up this vertical slab that's on the rooftop, that's just a concrete on one side, and on the other 3 sides it's lined with glass. That creates a convection, so we have basically hot air escaping from the top, and everywhere where we wanted to evacuate air from an enclosed space, in the dormitories and in the classrooms, we could just create an opening in that shaft, and that air would then be drawn out through convection, being pulled out from the roof. Now, obviously, if we're drawing air out, we need to be able to draw air in. So at the upper levels, we created just standard windows into the dormitories. So all of the dormitories have openable windows with mosquito screens. And by having the verandas on the south side, you limit, obviously, the solar influx from here. So you're protecting your classrooms and keeping those shaded to the north side. Underneath the building, within the width and depth of the foundation, we created a series of hume pipes. They're kind of massive concrete tubes that sit in between the footings. And by putting those on the north side and then planting vegetation in front of them, one, they're shaded because of the sun direction. They get a little bit of humidity from the plants themselves, and by watering those plants in the morning, that cool air is drawn in through those pipes. In the center of the building, it turns around and it comes back. Basically, the greater length you can have and the sort of more exposure to cooler temperatures that exist naturally, obviously, in the foundations of the building. The air that's drawn in from the outside is cooled further, and that then comes into the classroom at the floor level by having then just standard ceiling fans in each of those spaces. We also figured out ways that on the first floor level that those could come in to this side, but by having those ceiling fans mixing that air, you basically got a passive air conditioning system. What we realized also quite quickly is that if we were to leave our ceiling exposed and we were to use masonry floors, be it IPS, cement screed, the marble mosaics that we used, that the thermal mass of those two elements would create a kind of negative battery. Pune has, and this part of Pune especially because it's outside the city, has a significant temperature difference between day and night, even throughout the year. And so by cooling those spaces off, those slabs in the floor and ceiling would sort of have the potential to absorb heat, whether it was the heat of the sun or the heat of the students throughout the day, and keep that temperature comfortable. The classrooms were no longer occupied. They would cool down and be recharged for the next day. Given the sort of price constraints of the project, we knew that concrete would be something that we had to live with as a material. It became the most efficient way in terms of sort of local building technology, in terms of affordability, the sizes, the spans that we needed to achieve. We know that it's not the most sustainable material in terms of the air pollution that its production causes, but given the fact that everything was locally available, it just became the way forward. To kind of mitigate the sort of impact that the concrete had, we tried to look at sort of other more local materials, more natural materials. We made the bamboo screens, obviously the hand-tied from locally sourced bamboo. We worked with local artisans as well who had knowledge and expertise of that. Malakar Mama was invaluable in that kind of research and development. We worked a lot with recycled or reclaimed or what would otherwise be wasted material, things that were offcuts from tile shops or things that were wastage from quarries. All of the beautiful colors that you see in Rajasthan of the different kinds of marbles. We could generally get them at almost no cost or the cost of transportation, which enabled us to then take that material and invest a little bit more in the artisans, in the craftsmanship. The partitions for the walls are made out of recycled fly ash from industrial waste. We didn't even plaster them, so they're just laid in a very careful way. Because of connections that Rupa had, we were able to get them at a large discount, and so we actually laid them horizontally, so you get these kind of broad courses, which not only, in our opinion, looked nicer, but they also helped with insulation, both air and sound. We got 80 doors from an old school in Bombay that was being torn down. And so the cost for that was basically the same cost as buying a newly manufactured, synthetic composite material, aluminum and fiberglass or whatever those materials were. When you scrape all the paint and you realize underneath that it's old Burma teak from 80 years ago, it has this richness to it. It has this material quality. And so the challenge for us became, okay, how do we make all of these kind of mismatched elements come together and work? The integration of color, all credit for that really goes to Milena Bach. She's the one who said, no, actually we shouldn't paint the walls. We should leave the walls the way they are. The color should be on the ceiling. And it should integrate with the landscape, and it should be a kind of a wayfinding device, and it should give a sense of place so that no two spaces should have the same palette. She came here, she worked with Dwani, who was an architect on my team at the time, and they developed using local pigments, oxides, and things that we could get in the market here to create their own kinds of a paint. It's basically pigment, cement, water, a series of binders. It's kind of a material unto itself. So it has depth, it has thickness, it has texture, and the girls have really responded to that. The furniture was something we knew had to be flexible, had to be durable, had to be robust. We wanted it to sort of bring an element of color. Paint would be something that would be a kind of not just desirable in terms of color, but also an affordable finish on the steel. We wanted them to be lightweight and transportable. Two girls could easily pick up and move a table. We tried to design them in a way where they could be fit together in a cluster of 3, 4, 6, whatever. You could make them in a row, you could make them in a circle, you could sort of take the sort of nominal Roman camp version of students in a row. We wanted to create a series of benches and chairs for the library. We wanted to use a reclaimed material. And we found in Surat in the north, where there's a lot of sort of textile industry, there were places that were making these threads and these ropes out of industrial waste left over from weaving. You can get these same ropes made out of like potato chip wrappers and cellophane and things like that. And so we looked at a series of outdoor furniture as well using these, because the plastic would perhaps behave better. Paul Michelon, who was a designer that had worked with us at the time, made these very beautiful kind of long benches that had this and a wooden plank at the base, and then had this woven back. All of the floor slabs could be reconfigured. So let's say one day you needed to remove 3 classrooms and add 14 more dormitories. You could take one floor, take down the partition walls, put up new ones, and you're ready to go. Any project that we do, certainly one of this kind of scale and of a public nature, is to try and imagine it as a hospital, as a library, as a museum, as an office, as a hotel. And so for us, as we were working through these, everything from orientation, position in the landscape, structure, was to try and imagine it specifically as a school, but also independent of really any program. If Avasara ceased to be or changed its mission and wanted to become a museum, or it wanted to become a training facility, or it wanted to become an office, or it wanted to become, an artist in residency program, would the spaces still support that? For us, the greatest form of sustainability is to create things that have a kind of lasting value, independent of their program or kind of function or use at that moment. My kind of preconceived notions about the kind of power of collaboration and the potential that leads to have all just been, unwaveringly reaffirmed. When you come to people with an idea, with a program, with a project that has the potential that something like this has, just the sheer idea of a place like this was inspiring in and of itself. But people were, kind of lining up and agreeing to kind of work on different parts and different elements, from the people we hired as contractors coming with, over and above their roles and responsibilities to come up with ideas about how we could save money, how we could do something better, more efficiently, more productively, to people like Malena and Pratik. We engaged with local farmers. We brought permaculturalists from Zanzibar, Emira Nakashima. All of these different characters each contributed something that goes way above and beyond what we as architects could even imagine for ourselves. The first year, another part of the valley, we created a small annex where the first batch of girls started in that, just 3 simple classrooms in a kind of old manager's building. But once the first building was ready and the girls came on campus, the whole space kind of came alive. You can do what you want as an architect, but until it's sort of inhabited in a kind of rich and meaningful way, and the light and the energy that these young women have is incredibly inspiring. And Rupa kept asking for this sanctuary for learning, and I hope we've kind of created a foundation for that.